Hello and good morning, CTS267, Section 840 students for the Spring 2017 semester at Anne Arundel Community College. This is the CCNP TSHOOT course, and this morning's video tutorial is going to be a tutorial and solution set for challenge number 13, where we're going to be taking a look at some trouble tickets in the Bank of Polona network. And as you can see here, we've added in some additional devices. The Bank of Polona has 3 remote branch networks here. And then we've got our headquarters network. We've got 2 distro layer routers here. We've got an access layer switch. And so let's go ahead and dig in and see what tickets we are going to be working on. So it looks as if the Bank of Polona just purchased branch 3. Now this is going to be key here as I'm looking at this. The newly acquired branch is configured with EIGRP. The headquarters and other 2 branch offices are configured with OSPF. And so as soon as you read this, you should be thinking to yourself, there's probably a redistribution issue somewhere, because we've got EIGRP coming from branch 3, but everybody else is running OSPF. At some point, they're going to change that EIGRP to be OSPF, but right now we're going to have to troubleshoot some issues. So as we scroll down here, all right, so we'll tackle these in order. So the user from the newly acquired branch office, surprise, surprise, cannot access server SRV2, which sits over here behind branch 2. The user sits behind PC3, right? So the user's on PC3 and they're trying to come up through the internet. My guess is they've got some sort of hub and spoke crypto going on here, so we'll take a look at that. Probably not going to be DMVPN. It may just be individual crypto maps applied to the internet-facing interfaces. So let's check that out. So let's go ahead and dive in here. And when we think about a troubleshooting scenario, in fact, you'll notice we can't click on PC3. I just realized that. And we can't click on branch 3. We can't click on branch 2. So none of the branch devices can we console to. We can get to HQ, router 2, router 1, and switch 1. So let's start our troubleshooting methodology out with confirming the issue. And so I'm going to need some IP addresses here. Specifically what's going on at branch 3. So 192.168.3.101, and then PC3 is 3.100. And so I'm going to jot those down real quick here. 3.100, 3.101. So these are the addresses we're going to be looking at. And it says telnet from HQ. So this is critical, right? Because this is explaining to us how we're supposed to connect through. So I'm going to jump on the HQ router, and let's go from user exec to privilege exec, and we're going to say telnet, and I'm going to get to the PC, 192.168.3.100, and this should take us over to PC3. And do we not have connectivity? It looks like we can't get to PC3. Okay, that's good. Not a problem. We'll go to branch 3, and we'll get our password in. We'll go from user exec to privilege exec. And let's see, I probably should have written the IP address of SRV2 down, which is 2.200. So what happens if I try to ping 192.168.2.200? Yeah, so we're getting that destination unreachable, and so that's typically a problem with, let's say, show IP route 192.168.2.0. Let's see if we have that network on our table at about 2.200. No, nothing. So just show IP route, and let's take a look here. And so we see a whole bunch of 172s. And then we see our 192.168.3, right? So we see the directly connected network, but we're not seeing any of the other networks. And so remember, we're running EIGRP. So when I say show run section router EIGRP, right, that's what the EIGRP section looks like. So if there was redistribution going on, right, and this is sort of the first clue, if there was redistribution going on and we were receiving the routing information from the headquarters router, because if I were to say show IP interface brief, you can see that Ethernet 00, that is our internet-facing interface, and we have a tunnel interface here from HQ, which I guess they're going to say is site 1 to 3, which is us branch 3. So there's a tunnel interface. So when we look at show run int Ethernet 00, you're going to see, yes, and there it is, CryptoMap VPN. So this is clear hub and spoke setup here. So let's do this. It's clear that there's something wrong with the routing, and my guess is just by looking at the routing table, right, what would we expect? Back to that question, what would you expect to see here if OSPF was being redistributed into EIGRP? What would we be looking for? Would it be OSPF OE2 external routes that we would see here? Or would it be DEX for external EIGRP routes? Exactly. So this router's running EIGRP. We would anticipate that the HQ router would be redistributing its OSPF routes into EIGRP. That way, this branch office would have the additional routing information that it's going to need in order to communicate with the other branches. And so from branch 3, this is going to lead me back to the HQ router. So the HQ router is running show run section router EIGRP. It's clearly running EIGRP, and we have just stumbled upon the issue, actually. So when looking at this, what do you think the problem might be here? Yeah, we know it's something to do with redistribution. It's not the network statement, because we know that if I were to say show IP EIGRP interfaces, that we need EIGRP running on that tunnel interface in order to establish the adjacency with that branch router. So the network statement is good. You may think, well, what about auto summary? Well, no, not really an issue right now. If I was to say show IP protocols, and we were to come down, and actually, were we EIGRP 100 there? Yes. EIGRP 100. If we were to take a look at automatic summarization, right, that doesn't really play into things. So the issue is the only other statement that we have in here. It's this redistribute OSPF 1. So remember, when we're redistributing from OSPF or from any other routing protocol, let me clear that up. When we're redistributing from any other routing protocol into EIGRP, what do we need? Because remember, it's no longer apples to apples at that point, right? We're sort of mixing routing protocols. And so what do we need to give EIGRP so that it knows how to properly seed these OSPF routes that are going to be coming into EIGRP? Exactly. We need the EIGRP metrics to be added in. So let's get into global config, and let's say router, oops, sorry, I did not want that, router EIGRP 100. Let me get that up again. Do show run section router EIGRP. Okay, so we're going to say no redistribute OSPF 1. Let's rerun that command. So that's all we have right now. And again, remember, the redistribute command was incorrect, right? So let me say, let's say do show run section router OSPF. I just want to take a look at that real quick. All right, so there's quite a bit of OSPF information. Do show IP route OSPF. So, and there are the missing prefixes that we need branch 3 to be able to receive, right? So 192.168.0, that's HQ. We've got the .1, and actually .1 is HQ as well, I believe. And then we've got 192.168.2. And that, remember the 192.168.2, that is over at branch 2. And it looks like .1 is going to be branch 1. And it looks like the 0 here is the internal network at the headquarters, right? So what do we need to say? Well, we need to say redistribute OSPF 1, but remember, we need to tell EIGRP what the metric's going to be. And so common metrics that are used are 1500, 10,000, what is it, 1 or 255, 1, 1500, something like that. So again, really not that important as to what metric we put in here, as long as we do put in some metric values. And I would say the only caveat to this is don't put 11111. Don't put 5 ones. Try to get out of that habit, because when we get into named EIGRP, or 64-bit mode, as it's commonly referred to, when you're doing redistribution statements, you can no longer just throw the 5 ones in there. It used to be commonplace that you could say redistribute OSPF 1 metric 11111 and you'd be fine. You can no longer do that with named mode EIGRP. You can run into some issues where the prefixes and the routes that you're advertising won't actually get advertised because they'll have a max metric. So that was what was missing, right? We need to tell EIGRP, hey, I'm giving you these OSPF routes, right? So I'm redistributing from OSPF into EIGRP, and here are the composite metric values, the K values, that need to accompany, right, or need to be assigned to the OSPF routing information that is now no longer OSPF routing information. It is now going to be external EIGRP routing information, and we can see that if I were to telnet back over to 192.168.3.101, I think it was, yeah. And let's get into privilege exec. All right, so now we say show IP route, excuse me, and there we go. I was getting nervous there for a second because we had all these 172s in front of it. So in fact, let's trim this down. Show IP route EIGRP, and now we are receiving all of the EIGRP routing information that we anticipated, or that we would anticipate we would get. So here's that HQ network, 192.168.0.0. There's the 192.168.1, and there's the 192.168.2. And again, these will all be DEX, right, for dual EIGRP external routing information, administrative distance of 170. And you'll notice here's the metric value, right? The composite metric is the same for all of these routes, and that's supposed to be that way, right? Because we've assigned all of them the exact same metric. All right, and so then our next hop, or who we're learning everything from, is 192.168.13.2.2, right? The HQ router. And how do we get to that? How do we get to that information? Well, we're going to go across tunnel 3. So let's go ahead and check our reachability right now that we've addressed that redistribution issue. And let's say we were trying to ping, I think it was 192.168.2.100. All right, fantastic. So we've got connectivity over there to server 2, and so this issue appears to be resolved. If I were to go back over here, let's actually pull up our next scenario. So Tina noticed that if the R1 uplink fails, and so what we're talking about here is the uplink from R1 up to the HQ edge router, or the core router up here, and then to R2 instead of directly to R2. Okay, so I'm sorry. So if the uplink fails, all the traffic from PC0 goes to R1, so it shoots up this way and then comes right back down and goes that way. So let me erase this here. Sorry about that. I was reading that backwards. So again, PC1 has traffic that comes up here, but if this link is dead, the traffic then hairpins and comes back this direction, right? And so we can be guaranteed that it has something to do, right? We get this nice mention here that VRRP is the issue. They want to do HSRP, but they're not allowed to per company policy, and that policy might be in place. VRRP is an open standard, so maybe the policy is in place because, who knows, they may want to be putting a Juniper router in here, God forbid. And I say that jokingly, but that's one of the reasons why you would go with VRRP, right, as an open standard. You're not required to have Cisco hardware, where HSRP and GLBP, right, the Gateway Load Balancing Protocol, those are both Cisco proprietary and are going to require Cisco hardware. So she would like to implement interface tracking, but is not allowed to configure. So HSRP, right, has that built-in interface tracking, super convenient. VRRP does not, but we can use enhanced object tracking, right? Or we can track a line protocol if we needed to. And so that's actually what we're going to be doing here, is my guess, is what we're going to be doing here, eliminate suboptimal traffic. So troubleshooting methodology, we've got a lot of tips, right, in terms of where to begin to look. So first off, let's confirm that the issue exists. So I'm going to get onto router 1, and we're going to say show IP interface brief. And my guess is, actually, I don't have a guess here as to which link is which. Let's see if the job aids gives us the physical Yeah, so the uplink is Ethernet 01. So back on router 1, if I was to go into global config, Ethernet 01, and say shut, let's go ahead and come down to PC0 here. And do we have an internet address? Actually, I guess we could just go to any address. So let's check. We'll go to PC3, in fact, which we just fixed, so this should work. 192.168. Is it 3.100? So let's see, can we ping out? And we can, but you'll notice, right, that we're working. And so this is probably one of the tougher issues to troubleshoot without that information that, hey, she wants to do load balancing, or I'm sorry, HSRP, and possibly do something there, and that VRRP is installed. Without that information, this may be difficult, because we're seeing here that, yeah, well, the traffic is working. But we know from the write-up that it's working because if I trace the traffic out to 192.168.3.100 or 101, either of those addresses gets us to branch 3, and we should have done numeric there. There we go, they kind of rushed it along, so we'll do the numeric. And so you can see that we make that first hop, right? We go to 192.168.0.254, and so this may be the virtual IP for VRRP. We then go to 222.2, 13.1. We know that that is the HQ router. We make it up to the HQ router, and then we make it over to, I'm going to say that that's the R3 over at the branch. I think the PC was 101, but irrespective of where we're at on branch 3, what we're looking at is we hit the VIP, right? But then where does it swing us to? Over to router 2. And so we shouldn't, excuse me, we shouldn't be going to router 1 and then back to router 2. And let's go ahead and get on router 1 and take a look. And again, we've got kind of an unfair, I shouldn't say unfair advantage, but an advantage in that we know, show run section VRRP, that it's probably something to do with VRRP. So show VRRP brief. Let's see what the status is here. So you can see that the priority here is 110. My state is the master, which means the secondary is going to be R2. So we come over to R2. Let's get into privilege exec and say show VRRP brief. And this gives us a lot of information. You can see the state is the backup. That is the address of the master. And oops, sorry, floating around here. And the VIP. Or actually, I'm sorry, the virtual IP is 192.168.0.1. So 253 is, yeah, 253 is the Ethernet 00 interface here. Excuse me. And so then 254 is where? So let's see, show IP interface brief. Okay, so 254 is where it came over to router 2. So it actually goes to router 2, and that's what we were looking for. And I don't believe we have any tracking turned on. So let's see here. So that's interesting that it goes to router 2. And then the 222.2, which is going to be that inside interface, is probably this link here with the HQ router. Let's do a show IP interface brief, show IP interface brief. And it is not. I don't see that 222 there. Interesting. I'm not sure where that 222 address sits. So let me reread this issue here, and maybe it is not an issue. So she noticed if the R1 uplink fails, all the traffic from PC0 goes to router 1 and then to router 2 instead of going directly to router 2. She would like to implement interface tracking. All right, so we know we need a tracking statement, right? We need to set up some enhanced object tracking. And let's see here for a second. Show IP interface brief, because that address... Yeah, so what's got me here is we're hitting, when we trace out, we're going to 192.168.222.2, but when I'm, oh, 222.1, there it is. I completely looked right by that. So Ethernet 01 on router 2 is 222.1. Let's see where that sits. Ethernet 01. Yeah, so it should go to the HQ router, but I didn't see a 222. Oh, it's branch 3. So, okay, problem solved. I was looking here at the HQ tab thinking I was on HQ, not realizing that I was still remoted into show IP interface brief, the HQ router, which is where that 222.2 address resides, which is what we would expect. But it doesn't seem that this is a problem because the traffic is actually not going to router 1 and then to router 2. It's going to 192.168.0.254, and that is the Ethernet 00 interface of router 2. So on router 1, we've got the right interface is shut down. Show IP route 192.168.3.100. VRRP brief. So now I'm curious. And we're picking that up in OSPF. There's an OE2 that's telling us to go towards router 2. So let's check something here. Let's global config. Let me bring back interface Ethernet 01 and say no shut, do show IP interface brief. All right, so all of the interfaces are up. How about a do show IP route to 192.168.3. There we go. The OSPF adjacency is back. And I wonder if that is what is being asked for here. Yeah, because now, so it looks like the interface going down, the uplink interface going down to router 1, is that OSPF is picking that up and making the decision, but that doesn't jive with the VRRP config, which clearly shows that even with that interface down, that this is the master and that this is where traffic should be making its first hop to. All right, so we're going to have to go under the assumption that they didn't anticipate that we were going to shut the interface down to confirm that there was a problem, because the VRRP is configured correctly. We're not tracking anything, but it is configured correctly. So now on PC0, when I run this trace again, and that's interesting. So it's still going to 2. So it's interesting that even with, and is this switch accessible? Let me make sure that this switch is not running show IP route, and it's not. Show VLAN. It should just be access layer switch. All right, looks like everything is in VLAN 1. Show run. And what port is the PC connected into? Ethernet 00. So yeah, so it's all VLAN 1, and Ethernet 01 and 02 are the same. Let's take a look here and see. Show MAC address table. So now we're drilling down, sort of going bottom up here to see, and there is the MAC address for VRRP. And it shows it on Ethernet 01, which was the correct interface here, Ethernet 01. So then the question becomes, why is the traffic transiting R2 even when that uplink is not down? And again, easy to confirm that. We can see right here it goes to 192.168.0.254, and that is clearly the router 2 address, even though the switch shows it going out Ethernet 0.1, which should take it over to router 1. So here's what I'm going to do. I'm going to reload this switch. And you got to love the reloads in IOL, much quicker. All right, so let's say show MAC address table. All right, we've got nothing so far. That's okay. Let's run some trace routes through PC0 here. And probably going to take an extra second. Taking a little longer than I... There we go. Okay. So let's trace it again. So yeah, it still likes 254. So that's interesting because that is not the direction it should be going because the state is backup. The master address is clearly 253. On switch 1, the show MAC address table, it's definitely supposed to go out Ethernet 0.1. So there's no reason it should be getting sent. And let me say, do show run section OSPF. Do show IP interface brief. And so we're running OSPF. All right, that's interesting. So we're running OSPF over this link here. So if I'm on R2, if I were to say do show IP OSPF neighbors, you can see that 10.1 out Ethernet. Let's double check that. Make sure that's Ethernet 0.1. So I'm checking to see right now out which interfaces. So Ethernet 0.0. Yeah, we've established OSPF over that interface. So let's do this. It appears that OSPF is preferring the path that it's a lower cost to come up and over to router 2 and then out, even with... All right, so let's do this. On router 2, we're going to... Actually, let me double check the interface. So on Ethernet 0.1, let's see if this does something here. So on Ethernet 0.1, let's get into global config, interface Ethernet 0.1, and I'm going to say IP OSPF cost 12345. Whoops, 99.99, right? Now let me come back to PC0. And see what happens with the trace. So take a look at that. So now we're going over to PC1 like we should have. So there's a couple things that we could have done here to fix that. That's interesting. And I'd be curious to know your feedback on Thursday if you ran into the same behavior, because OSPF is clearly preferring the path through router 2, and it seemed as if it's overriding VRRP, which it shouldn't. So now when I come up to router 1 and I say shut and we bring that interface down, this is going to take the adjacency down, right? The OSPF adjacency goes down between router 1 and the headquarters router. But now when we come back to PC1, it looks like now we go straight over to router 2. So I'm wondering if this is a bug of some kind or if I'm just missing something here. So, because clearly the issue isn't that the traffic's not right. It's that OSPF, it's that OSPF adjacency that's formed between router 1 and router 2 through the switch here. This OSPF adjacency here is sort of overriding the VRRP configuration. So here's what I'm going to do. We're going to say no shut, And we're going to go into router OSPF 1, do show run section router OSPF. And we're going to say, and are we going to be able to do this? So I want to get rid of that adjacency out Ethernet 00, which goes to router 2. So if I were to say no network 192.168.0.00.0.0.255 area 0, and then do the same thing over here on router 2. Do show run section router OSPF. Yeah, and that same statement exists here. So let's go ahead and say router OSPF 1 no network 192.168.0.00.0.0.255 area 0. Whoops, extra dot in there. So we're basically removing the OSPF adjacency through the switch. I'm curious if maybe this is some sort of an IOL bug or something. Do show IP interface brief. Okay, so interfaces are all up. We're good. PC0, what should it do? With VRRP, we should go to router 1 and then to router 2. And we're still going directly to router 2. And so this is interesting. Do show VRRP brief. So it's clearly the backup. Do show VRRP, and everything is up. State is backup. We've got the virtual IP. The MAC address is set. Preemption's enabled. Priority is 100, which is the default. And it sees the master, and everything is fine there because this is a layer 2 communication, right? It's going through the switch. Master down interval, that's fine. So why then is on router 1 do show VRRP, and this sees itself as the master, and that's not a problem. Priority is 110. So again, it's not clear. Even on switch 1, if we were to say show MAC address table, it still shows the traffic is supposed to go out Ethernet 01. So something, I'm maintaining that something is clearly not right here. And you can see it continues to go to router 2. So all the interfaces are up. So I guess back to the scenario, right? What is it looking for? Because something is not right here. And I don't believe I'm overlooking anything because everything looks fine. It's just that it's not functioning the way it's supposed to. So let's do this. If we had to track the interface, so here's how we would do this. We'd want to track that Ethernet 01 interface, and the tracking is very simple. We would just simply say track 1 interface Ethernet 01, and we're going to be looking at the line protocol. We go into interface Ethernet 00, VRRP1, track, and what track did we create? 1, and then we would decrement our priority, and I'll do it by 30. Right? So now when I say do show run interface Ethernet 00, you can see we're tracking so that if that Ethernet 01 interface goes down, when I say do show VRRP, the priority will decrement, and here we go. Beautiful, right? Track object 1, the state is up, right? The state's up because Ethernet 01 is up. If I go into interface Ethernet 01 and I say shut, and then say do show VRRP, and let's let this go by, take a look here. Track object 1, state is down, so we decremented by 30, bringing us 280. Remember, we were configured for 110, and now our state has changed from master to backup. If I come to PC0, oops, and we want to do numeric, we go to router 2, but it appears we've lost. And maybe on router 2, did I remove the wrong network statement? Do show IP OSPF neighbors, IP OSPF neighbors. So we should have a neighbor relationship with the HQ router, which is 10.1. And if we look here, we'll say show IP OSPF neighbor. Yeah, and we do have an adjacency here. And so that's not the problem. So let's go ahead. I'm going to leave this one because things are clearly not behaving the way they should. And let's bring the interface on on router 1. Let's bring that interface back up. Let's see if maybe bouncing it back and forth does anything. If I were to say do show VRRP, you can see that we're back up. Our adjacency with the HQ router has come back up. Do show IP route OSPF. And we'll give it a second here. There we go. All right, so it's got all the routing information. So now back to PC 0, and it still goes to router 2, even though switch 1, and what we should have taken a look at, so there it goes to Ethernet 01. If I come over to router 1, we should see that the MAC address should be advertised out. If we shut that interface down, on switch 1, this entry should change to Ethernet 02. And you see that? It does. So VRRP is doing what it's supposed to do. For some reason, which I can only ascribe to some sort of a bug here, that's not working. So we're going to leave this for now and go on to the final check here. And maybe this final ticket's got something to do with the behavior that we're seeing. So Tina's receiving reports from users in the headquarters that server 2 is sometimes inaccessible. Okay, so this is going to have nothing to do with the previous problem. So yeah, so trouble ticket 2, it's something with the IOU. Has to be something with the IOU. To confirm this, she configured IP SLA test on the HQ router that the test reachability. Okay, so this leads us sort of right to what the issue may be. She complains the test will not start. And typically, the problem is you've created the SLA, but you forgot to schedule the SLA. So show run section IP SLA. So there we go. We've got IP SLA 1, ICMP echo, frequency 30, but there's no schedule. So this will be pretty easy for us to schedule up here. So IP SLA schedule, and we'll do we'll just stick with entry number 1. And so when do we want to start? Or actually, we'll say life forever, and then start time is now. And that is it. And so that will actually start up the IP SLA schedule. So if I were to say do show IP SLA, whoops, do show IP SLA 1, it's not 1 here. I'm remembering show IP SLA summary is what I'm looking for. So there we go. So now we can see that it's actually running. If we were to take a look at show IP SLA statistics, that's the even better one. And that shows we've had no successes, 1 failure, right? Because again, we're simply trying to ping 192, so let's see if that works. Ping 192.168.1.200 out of... And so here's an interesting question. The scenario said that it was trying to ping server 2. Server 2 sometimes has reachability of server 2 around the clock. So the server 2 IP is what? I'm doubting whether that's the server 2 IP. Yeah, so the server 2 IP is wrong. So that's also an issue here. She's not actually pinging server 2, she's pinging server 1. So there's multiple hangups here. So let's fix this though. Let's make sure we get this correct. So that IP SLA is, as a former student Ken would say, that is bogus. So let's get into global config. Do show run section IP SLA. And so here's what we're going to do. We're going to create another IP SLA. So we'll say IP SLA 2, ICMP echo, and we're going to ping 192.168.2 dot, and I can never remember these IPs. 200? Let's see here. Yeah. .2.200. The frequency, we're going to set it every 5 seconds. And then let's get out of here and say IP SLA schedule 2 life forever start time now. And then say do show IP SLA statistics. So here's operation 2, right? And so this is supposed to be running. So if I was to say do ping 192.168.2.200, we can get there. Let's check our SLA, right? You can see we had an initial failure, but then here we should end up with successes, right? Take a look at the successes are incrementing every 5 seconds. We're sending those ICMP echo requests, and there we go. All right, so we had multiple issues here. There was no schedule for the existing IP SLA, but the existing IP SLA didn't even point to the server 2 IP address. So we had to resolve that as well. And then again, we had that, what I can only describe as a bug, and maybe if I was to exit all the way out or reset the activity, that would fix things. In fact, just so one last gasp, last ditch effort here, I'm going to reset all of the devices real quickly and go back in and see if resetting everything has any effect at all. So we're going to say reload config all. And this is for ticket 2, because there's clearly an issue with ticket 2. We could see it on the switch where it doesn't show the information that we're anticipating. So let's go to PC0. All interfaces should be up. PC0 is up. Let's get into privilege exec. Oh, now we're presented with the multiple characters. So I'm going to do this. I'm just going to leave this here, and we'll cut it off here, and I'll do it offline and let you know on Thursday if we're coming back in. You know, again, sometimes you have to exit all the way out of the activity like this, have it take you all the way back to the lab name screen with all the activities, then go back in, and sometimes that'll resolve things. So, all right, we'll leave it here. So thanks for watching, and I will see you guys on Thursday night. Have a great weekend.